Hello everyone, Imani and I are doing our final project video on Isaac Newton and his 3 laws. Sir Isaac Newton was a mathematician, an astronomer, a physicist, and an author. Today we still use his laws. The 3 laws of motion were first compiled by Isaac Newton in his Math Principles and Natural Philosophies. States that every object moves in a straight line until a force is acted upon it. The second law states the acceleration of an object is directly proportional to the net force exerted in proportion to every object mass. The third law states for every action there is an equal and opposite reaction. Some key terms that you should know would be force, strength/energy as of physics, inertia, property by which it continues in its existing state of rest or a straight line, unless being charged by external force, motion, the action/process of moving or being moved. Okay.
Hi, I'm Imani, and I'm also going to be talking about and actually showing y'all how the 3 laws work and telling y'all the real definitions.
Newton's first law is all about inertia, which is basically an object's tendency to keep doing what it's doing. It's often stated as an object in motion will remain in motion and an object at rest will remain at rest unless acted upon, known as mass. Say you have 2 balls that are the same size, but one is an inflatable beach ball and the other is a bowling ball. The bowling ball is going to be harder to move and harder to stop once it's moving. It has more inertia because it has more. The idea connects nicely to Newton's second law. Net force is equal to mass times acceleration. Or, as an equation, F net equals ma. It's important to cancel each other out. Let's say you have a hockey puck sitting on a perfectly frictionless ice rink, and I know they're not usually perfectly frictionless, but stick with it. If you're pushing the puck along with a stick, that's a force on it that isn't being cancelled out by anything else, so the puck is experiencing acceleration. But when the puck is just sitting still, or even when it's sliding across the ice after you've pushed it, then all the forces are balanced out. That's what's known as external force. Say you throw a 5-kilogram ball straight up in the air and then, get out of the way because that could really hurt if it hits you. But the force of gravity is pulling down on the ball, which is accelerating downward at a rate of 9.81 meters small g. So the force of gravity on the ball must be 5 kilograms, which is the mass of the ball, times small g, which comes to 49.05 kilograms times meters per second squared. We use this equation for gravity so much that it's often just written as Fg equals mg. That's how you determine the force of gravity, otherwise it tends to show up a lot, which is explained by Newton's third law. You probably know this law as for every action there's an equal but opposite reaction, which just means that if you exert a force on an object, it exerts an equal force back on you. And that's what we call the normal force, like a table. If you put a book down on a table, the normal force is pushing and therefore pointing up. But if you put it on a ramp, the normal force is pointing perpendicular to the bowl. And then you put one lonely grape on top of it, exerting a little bit of force on the foil, and the normal force pushes right back with the same.